2005 National Electrical Code, or NEC, addresses the use of various raceway types within concrete, including applications in patient care areas. Specifically, it allows for the installation of Schedule 40 polyvinyl chloride, flexible non-metallic, jacketed metallic raceways, or jacketed metallic cable assemblies that are listed for installation in concrete. This means that if these specific types of raceways are approved for concrete embedment, they can be used for portions of circuits, including those feeding patient care areas, while they are encased within the concrete. However, a crucial condition accompanies this allowance. Where the raceway exits the concrete, the NEC mandates the use of an approved metal raceway. This requirement ensures that the transition from the concrete encased raceway to the exposed environment is achieved with a raceway system that offers enhanced mechanical protection and grounding capabilities. The NEC specifications are designed to ensure electrical safety and reliability, particularly in sensitive areas like patient care facilities. It is important to understand the requirements concerning raceways in concrete, especially when dealing with essential systems like those powering medical equipment. The code distinguishes between raceway types suitable for direct burial or embedment in concrete and those that are not. For instance, standard electrical metallic tubing, or EMT, is generally not approved for direct burial in concrete unless it is specifically protected against corrosion. This is because concrete can be corrosive to certain metals over time. The allowance for Schedule 40 polyvinyl chloride and similar raceways is based on their inherent resistance to corrosion and their ability to withstand the physical stresses associated with concrete encasement. Flexible non-metallic raceways, or FNNC, offer flexibility in routing and are often used in short runs or where movement is anticipated. Jacketed metallic raceways combine the benefits of metallic strength with a protective jacket that shields the metal from corrosion. The key is that these raceways must be listed for installation in concrete, indicating they have been tested and approved for the specific application. The requirement for a metal raceway where the raceway exits the concrete serves several purposes. Firstly, it provides a robust mechanical transition point. The concrete encasement offers substantial protection to the raceway within, but the point where the raceway emerges is vulnerable to physical damage from impacts, abrasion, or other external forces. A metal raceway, such as rigid metal conduit, or RMC, or intermediate metal conduit, or IMC, offers superior protection against these hazards. Secondly, the metal raceway provides a reliable grounding path. Grounding is a critical safety measure in electrical systems, ensuring that fault currents can safely return to the source, tripping circuit breakers or ground fault circuit interrupters, or GFCIs, and preventing electrical shock hazards. A properly installed metal raceway system provides a continuous grounding path, enhancing the overall safety of the electrical installation. Thirdly, the metal raceway can help to mitigate fire hazards. While the concrete itself is non-combustible, the raceway exiting the concrete may be exposed to combustible materials or high temperatures. A metal raceway offers better fire resistance compared to non-metallic alternatives, helping to contain a fire and prevent its spread. When selecting a metal raceway for the transition, it is important to choose a type that is suitable for the specific environment and application. Rigid metal conduit, for example, is a heavy-duty raceway that offers excellent mechanical protection and is suitable for both indoor and outdoor use. Intermediate metal conduit is a lighter-weight alternative that still provides good mechanical protection and is often used in commercial and industrial applications. Electrical metallic tubing is a thin-walled conduit that is suitable for dry, indoor locations where it is not subject to severe physical damage. Regardless of the type of metal raceway selected, it must be properly installed in accordance with the NEC. This includes using appropriate fittings, supports, and grounding methods. The fittings must be listed for use with this specific type of raceway and must provide a secure and watertight connection. The raceway must be supported at the intervals specified by the NEC to prevent sagging or displacement. The grounding system must be properly installed to ensure a continuous and effective grounding path. In patient care areas, electrical safety is of paramount importance. These areas contain sensitive medical equipment that can be affected by electrical disturbances and pose a risk to patients if not properly installed and maintained. The NEC has specific requirements for electrical systems in patient care areas, including requirements for grounding, isolation, and leakage current. These requirements are designed to minimize the risk of electrical shock and ensure the reliable operation of medical equipment. When installing raceways and concrete in patient care areas, it is essential to comply with all applicable NEC requirements. This includes using listed raceways, properly installing the metal raceway transition, and ensuring a continuous and effective grounding path. It is also important to coordinate the electrical installation with other building systems such as plumbing, HVAC, and fire protection to ensure that the systems are compatible and do not create any hazards. Proper planning, design, and installation are crucial for ensuring the safety and reliability of electrical systems in patient care areas. Furthermore, the NEC is not static. It undergoes revisions every 3 years to incorporate new technologies, address emerging safety concerns, and improve clarity and enforceability. Therefore, it is crucial to consult the latest edition of the NEC when designing and installing electrical systems. The allowance for specific raceways in concrete, coupled with the requirement for metal raceways at the point of exit, represents a balanced approach to electrical installations. It leverages the benefits of concrete encasement for protection and corrosion resistance while ensuring mechanical strength, grounding integrity, and fire safety at the critical transition points. When working with electrical systems, always prioritize safety, adhere to the NEC, and consult with qualified professionals when needed. The specifics of NEC Article 517 address healthcare facilities. Section 517.13 covers grounding of electrical equipment in patient care locations. The performance requirements for branch circuits serving patient care spaces are detailed in 517.19. This section stipulates that branch circuits serving patient care beds must be provided with a ground fault circuit interrupter, or GFCI, protection. Section 517.30 addresses the essential electrical systems for healthcare facilities. It divides essential electrical systems into two categories: life safety branch and equipment branch. The life safety branch provides power to critical systems such as emergency lighting, fire detection and alarm systems, and critical care areas. The equipment branch supplies power to equipment that is essential for patient care but not necessarily life-sustaining, such as heating, ventilation, and air conditioning systems. Section 517.60 provides additional requirements for the wiring and equipment in patient care areas. It requires that all electrical equipment in patient care areas be listed for the intended use. It also prohibits the use of certain types of wiring methods in patient care areas, such as flexible cords and cables. In summary, the use of Schedule 40 polyvinyl chloride, flexible nonmetallic, jacketed metallic raceways, or jacketed metallic cable assemblies listed for installation in concrete is permitted within the concrete, even in patient care areas, provided that an approved metal raceway is used where the raceway exits the concrete. This configuration ensures both corrosion resistance within the concrete and mechanical and electrical protection at the transition point, adhering to the stringent safety requirements of the NEC, especially in health care facilities. The overall intention of the NEC is to provide a practical and safe standard for electrical installations. It represents a consensus-based approach, bringing together experts from various fields to address potential hazards and promote best practices. By adhering to the NEC, electrical professionals can contribute to the safety and well-being of the public.